Okay, so have you ever noticed how AI, like all those large language models we hear about, are amazing at spitting out facts and figures?
Yeah.
But when it comes to remembering details from, say, paragraphs ago, they kind of fall flat.
Oh, absolutely. Like remembering things from pages back.
Yep, it's a challenge. It's like trying to recall what you ate for breakfast last Tuesday.
Right. Like that's tough for us as humans, too.
Exactly. Our working memory has limits, so how can we expect AI to be any different, right?
Yeah, and especially when you think about how fast these AI models have to process information, like making connections and generating responses all at the same time.
It's mind-boggling. So what happens when the AI needs to recall something from way earlier in the text? It's like finding a needle in a haystack made of data.
Yeah, it is. It's a huge challenge, and it's something that this new research paper on LM2 tries to address.
LM2, what's that stand for?
LM2 stands for Large Memory Model, and it's like a completely new way of thinking about AI memory.
Okay, now you've got my attention. So is LM2 just a souped up version of the language models we already have, or is there something fundamentally different happening here?
It's actually pretty different. While LM2 uses the transformer architecture, which is like the foundation for models like ChatGPT, it introduces this separate memory bank. They call it M.
Oh, interesting. So instead of trying to cram everything into its immediate processing space, LM2 has this extra memory bank to pull from,
Yeah, exactly.
like having a super organized filing cabinet for thoughts and knowledge.
You got it. And it's not just storing stuff passively either. It's actively managed and updated through a system of gates.
Hold on, gates. Are we talking about like digital gates guarding those precious AI memories?
You could think of it that way. These gates are actually mathematical functions that decide what gets remembered, what gets forgotten, and how much that stored memory affects what the AI says.
Wow, so there's a lot of active decision making happening within that memory bank.
Right, and that's a big part of what makes LM2 so innovative. It goes beyond simple memorization and into this territory of using memory in a more nuanced and, dare I say, human-like way.
This is fascinating. So we've got this AI with its own memory bank, gates controlling the knowledge flow, and this whole idea of dynamic memory management. But does it actually work? Like, how do we know it's not just a fancy concept?
Well, the researchers put LM2 through a bunch of tests using benchmarks, and the results are honestly pretty impressive. They used this benchmark called BABILong, which is specifically designed to test how well a model can handle tasks that require a good memory, like remembering details from earlier in a text.
Okay, so spill the beans. Did LM2 ace the test?
It does. It totally crushed it. Compared to other models that have memory augmentation, like RMT, LM2 showed some significant improvement, getting a score that was 37.1% higher.
Whoa, that's a big difference. But memory isn't everything, right? Can LM2 do more than just remember stuff? Like, can it handle tasks that require more general knowledge and understanding?
That's a good question, and to test that, the researchers also used a benchmark called MMLU. It covers a wide range of general knowledge topics.
So how did LM2 do?
It did amazingly well, and what's even cooler is that it didn't just perform well, it actually scored 5% higher than a regular llama model.
So it's not just a memory whiz, it's using that memory to actually understand and process information better. That's pretty impressive.
Yeah, and it gets even more exciting because the researchers didn't just stop at measuring performance. They actually used something called the neuron explainer to kind of peek inside LM2's brain.
Now let's get into the city-gritty. So what did they find? Like, is it just a jumble of facts and figures in there?
Well, what they discovered is that there's actually a kind of specialization happening within the memory bank. Different memory slots seem to be developing expertise in different types of information, almost like having a team of experts collaborating inside the AI's mind.
Wait, hold on. So different parts of the memory bank focus on different things. This is getting really interesting. But how do they all work together?
Well, that's where these things called cross-attention heat maps come in. They help us see how the AI's attention shifts during a task. Like imagine a heat map of a city where brighter areas show more activity. In this case, those bright spots would show us which memory slots are being used most at any given time.
Oh, I see. So by looking at those heat maps, we can actually see LM2 thinking in real time.
It's kind of like that. And what's cool is that the heat maps show a really dynamic process. Like the AI's focus isn't fixed, it's always shifting and changing as it processes information.
So it's not just pulling up information randomly, it's actually focusing on the most relevant parts of its memory bank as it works through a problem.
Exactly. And those gates we talked about before, the forget input and output gates?
Yeah, the ones that control the information flow.
Well, they're playing a huge role in orchestrating this whole memory symphony. They allow the AI to really fine-tune its focus, filtering out distractions and highlighting the most important information at any given time.
So it's like the AI has its own internal conductor, guiding the orchestra of its memory bank to create a harmonious and meaningful output.
You got it. And to really understand how these gates work, we need to get a bit more technical and look at the mathematical equations that make it all possible. Don't worry, I'll try to keep it simple.
Okay, I'm ready to dive into the math. Let's see the equations that power this memory marvel.
All right, so one of the key equations that governs the memory update process is
Okay.
m sub t plus 1 equals g sub n times canH of e sub mem plus g sub forget times m sub t.
Whoa, that sounds pretty intense. Could you break it down for me?
Sure, so basically m sub t plus 1 represents the updated memory bank at a particular point in time. It's what you get when you combine new information with the existing memory, but in a really controlled way.
Okay, so it's not just dumping everything together.
Right, and that's what those gates come in. G sub n is the input gate, and it's a value between 0 and 1 that determines how much of the new information, represented by E sub mem, should be incorporated into the memory.
Got it. So if G sub n is close to 1, it means the new information is super important. It gets a big weighting.
Exactly. And G sub forget is the forget gate, also between 0 and 1. It controls how much of the existing memory, M sub t, gets to stick around.
So if G sub forget is close to 0, it means the AI is basically hitting the reset button on that part of its memory.
Yep, you got it. And that tan function is just a mathematical function that helps scale the new information so it fits in nicely with the existing memory.
Okay, so this equation is basically the recipe for how the memory bank learns and adapts, taking in new stuff while also getting rid of things that aren't important anymore.
Exactly. And that's what makes LM2's memory so powerful. It's this dynamic process of input, forgetting, and integration that allows it to handle really complex information.
This is blowing my mind. We've got this AI with this incredibly sophisticated memory bank, a system of gates to control everything, and this amazing ability to make connections across different parts of the text. It feels like AI is taking a giant leap forward in terms of being able to think and reason like we do.
I totally agree. LM2 is definitely a big step towards AI systems that can handle all sorts of complex information, make inferences, and solve problems that go way beyond just recognizing patterns.
It's super exciting to think about all the potential applications, like AI assistants that can actually understand and remember long conversations, or AI researchers that can dig through tons of scientific papers and pull out the most important insights, maybe even AI writers that can come up with stories that have intricate plots and characters we actually care about.
Absolutely. The possibilities are endless. And what's really cool is that LM2 isn't just a black box. We can actually look inside and understand how it's learning and making connections thanks to those tools we talked about earlier, like the neuron explainer and those cross-attention heat maps.
This has been an incredible journey into the world of AI and memory. It feels like I've learned so much about how language processing works and all the amazing advances that are happening in this field. I can't wait to see where this research leads us next.
Me too. And speaking of exciting new developments, there's another aspect of LM2 that I think you'll find really fascinating. It involves something called cross-attention, which lets the AI connect different parts of a text together, almost like a person underlining important phrases and making notes as they read.
Ooh, that sounds intriguing. I'm definitely ready to hear more about that. But first, I think we need a quick break to process all this amazing information. We'll be right back to delve deeper into the world of LM2 and its mind-blowing capabilities. Okay, so before the break, we were talking about peeking into LM2's brain and how different memory slots are like specialized experts. I'm ready for more mind-blowing insights.
All right, well, get ready because it gets even cooler when we look at how this specialization actually plays out. The researchers use this tool called the neuron explainer.
Right, you mentioned that.
Yeah, and it basically helps us see what individual neurons in a neural network are focusing on. It's like having a little window into the AI's thought process.
So we can see which neuron light up when it's thinking about different things.
Exactly. And what they found was pretty remarkable. Some memory slots were super attuned to factual information. They'd consistently activate when the AI came across dates, names, definitions, anything you could classify as a hard fact.
So it's like one part of the memory bank is a walking encyclopedia, always ready to spout off facts and figures.
Precisely. But then you had other memory slots that seemed to be more specialized in understanding the structure of information. These neurons would fire up when the AI was processing things like sentence syntax or how ideas were connected logically, or even just the overall flow of a text.
Interesting. So it's not just about remembering the facts, but also understanding how they relate to each other, the logic behind them.
That's exactly right. And this kind of specialization within the memory bank is what allows LM2 to go beyond just recalling information. It can actually start to reason about things, pull together different types of information, and synthesize it to come up with answers that require a deeper level of understanding.
This is incredible. So we have these specialized memory slots, but how do they actually work together? Like, how does the AI know which expert to consult at any given moment?
So that's where those cross-attention heat maps we talked about come in. These are visual representations that show us how the AI's attention shifts during a task. Remember that heat map of a city we talked about earlier?
Yeah, where the brighter areas mean more activity.
Right. Well, in this case, those bright spots on the heat map show us which memory slots are being accessed and used most intensely at any given time.
So it's like we're watching the AI think in real time. We can see its attention jump from one memory slot to another as it's working through a problem.
That's a great way to put it. And these dynamic shifts in attention are directly tied to those gating mechanisms we discussed earlier. Remember those forget, input, and output gates that control what goes into and out of the memory bank?
Yeah, they're like the bouncers at the memory nightclub, right?
Exactly. They allow the AI to fine-tune its focus to filtering out distractions and amplifying the most relevant information at any given moment.
This is all starting to make sense. So we've got these specialized memory slots, the gates controlling the flow of information, and these cross-attention heat maps showing us how it all comes together in real time. It's like watching a symphony of memory and attention playing out inside the AI's mind.
That's a beautiful way to put it.
Whoa, did someone just break the fourth wall? Let's hear it.
Oh, thank you for explanation. Can we wrap up with the research venues?
Of course, we can definitely talk about where this research was presented.
Yeah, let's definitely honor that request. Then we can talk about cross-attention.
Great idea. Okay, so this research on LM2 is pretty new.
Yeah, that's right.
The paper you can find is titled, well, LM2, Large Memory Models for Enhanced Context Reasoning.
And the correspondence author, Jikun Kang, can be reached at jikun@convergence.ai.
Cool. Also, there's a website, convergence.ai, and the code is on GitHub, convergence-ALM2.
This work was based on the Llama 3 model framework.
Okay, so now that we've wrapped up the research venues, should we talk about cross-attention?
Yeah, cross-attention.
You said it lets the AI connect different parts of a text.
Almost like a human underlining key phrases.
Exactly. It's a crucial part of how LM2 understands its memory bank.
It's like having a highlighter and a notebook.
Instead of just reading word by word, the AI can jump around.
It can make connections and get a deeper understanding.
Traditional transformers mostly focus on processing things sequentially.
But with cross-attention, LM2 can pay attention to multiple parts at once.
So the AI is reading with a bird's eye view.
It takes in the whole picture instead of getting bogged down.
Making connections across different parts is essential for reasoning.
It helps draw conclusions based on different pieces of evidence.
So how does cross-attention work in practice?
Cross-attention calculates a score for every pair of words.
So the higher the score, the stronger the connection.
Yeah, it is like a heat map showing what the AI is focusing on.
Those connections aren't fixed, are they?
Exactly. The AI can adapt and refine its understanding.
It's like watching a detective solve a case.
LM2 uses its memory bank to draw on past experiences.
This is seriously impressive stuff.
AI can handle really complex information.
Imagine AI assistants that can remember long conversations.
It's mind-blowing.
It's amazing to think about what we could do with this.
Yeah, it is truly mind-blowing.
What an incredible journey.
Well, that's all the time we have for today.
Thanks for joining us.
Until next time.